Hey everyone, I'm Sabah, a security architect, and this is episode 4 of my Security Architect Playbook series. In this series, I break down real architectures and show how security architect actually assess them layer by layer, focusing on the trust boundaries, the blast radius, and multiple failure paths, what that particular architectures have. If you haven't watched the earlier episodes on the Zero Trust or the basic three-tier app and also the API gateway, I'd recommend you starting there. They build the foundation of today's session as well. But now let's get into CI/CD and software supply chain security. So this is an architecture assessment walkthrough, as I already mentioned, meaning I'll show you how a security architect thinks when we look at the pipelines, the trust boundaries, and why this layer quietly causes some of the worst incident in the industry. So moving on, the agenda today will be first, I'll show you the overall CI/CD architecture so that we are grounded. Then we'll walk layer by layer, developers, source control, pipelines, the build environments, artifacts, and deployment, right? After that, I'll explain how to assess this architecture from a security perspective. I'm not going to show you how to build it, right? Finally, we'll close with a checklist as usual, and also I'll explain you some common failures, what I see over and over while these assessments. This is all about thinking, not memorizing control. So you have to keep this on top of your head. Now, coming to the architecture, right? So at a very high level, this is what happens. Developers write codes and push to the source control. That triggers a CI/CD pipeline which will build, test, and package the application, right? So those build outputs become artifacts, images, your packages, whatever, right? So which then get promoted and deployed into a runtime platform like your Kubernetes or any cloud services. Now, from a security architect's perspective, looking this diagram from a very high level, right? The entire flow is one long trust chain. If trust breaks early, everything later just inherit the same problem. So this is why supply chain attack are so effective everywhere, right? So they poison the beginning. They are not like coming in middle. Now, developer and identity layer. So this is where usually the trust starts. Developers are all humans, right? So humans make mistake. They sometimes reuse password. They also fall for phishing, and sometimes even they leave the company angry. So security architects look here first, right? So what they look into is who can commit a code, who can approve all the merges, who can trigger a pipeline, right? So identity in this case must be centralized, which must be enforced with MFA and also tightly scoped, right? And if developers have any excessive rights here, the rest of your controls are just decoration. It's not going to be helpful for you. And then source code management layer. So source control is not just storage. So it's a control plane literally, right? So again, as a security architect, we assess things like can anyone push directly to main branches? Are all the changes reviewed? Can you prove who authored a commit and why it was done? Right. So all these things need to be assessed at this layer. So if your source control is weak, attackers don't need a 0 day, right? So they just become contributors to all this. So security architects care less about tools, but more about the change integrity and accountability at this particular layer. And then comes your CI/CD pipeline control plane itself. So this is where many teams completely lose the plot, right? So pipelines are not scripts. Pipelines are identities with superpower, right? So they pull code, they can fetch secrets, they build artifacts, and these pipelines deploy to environments human where like human are not allowed to touch, right? So means it is powerful. So when assessing this layer, one of the key question, and I'll say only key question is, does the pipeline have more power than it should, right? So overprivileged pipelines are basically production admins that will never sleep. So we need to be cautious at that as well. Then comes your build and execution environment. Now we look at where build actually runs, right? From a security architect's view, the build environment must be disposable, isolated, kind of boring, right? So long-lived runners or shared build host or even your stateful environments, all these are like massive risk amplifiers. So if one gets compromised, does it affect the next one? So we actually need to focus on this particular question, right? So if yes, you built a malware factory, it's going to create multiple malwares and then just commit push everything. So we'll end up like assessing this layer from this perspective. And then comes your secret and credential management. So actually this slide exists because secrets are still treated like configuration files in many organizations. So secrets should never live in the code. It shouldn't live in the pipeline config. And also it should never live in the build logs or environment files committed to the repos. So we need to make sure, yeah, secrets are not living in all these places. And again, as a security architect, you should ask yourself, are secrets short lived? That's important, right? And are they injected only when needed? And can we revoke them instantly if something is compromised? So, if the answer for any of this is a no, the blast radius is already large in the architecture. Now comes the artifact management and the integrity part around that, right? So this is the most ignored layer as far as I see everywhere, right? So artifacts are the actual product of your pipeline itself, not the code, not the pipeline, but the artifact I'm talking about, right? So what we assess here is, can artifacts be changed after publishing? Are they actually signed? Can anyone upload directly to the registry? Again, the answers are supposed to be no, right? So if you cannot cryptographically prove where an artifact came from, you're just trusting some vibes. So we need to make sure we have an answer and we have ability to backtrace and see from where exactly it is coming from. And then comes your policy enforcement and validation piece of it. This is where your zero trust quietly show up again. So before anything is deployed, policy should answer some questions like, is this artifact allowed here? Was it built by the right pipeline? Was this signed? Yeah. And did it pass all the required checks in the pipeline? So the answer is supposed to be yes for all this, right? And security architects want the preventive enforcement, not dashboards that tell us something bad already happened. So we need to make sure this layer is secured as well. And then comes your deployment and the runtime handoff side of it. So this is the moment the trust is actually getting transferred. The run environment, Kubernetes or cloud, should not trust the developers, right? So it should not even trust the pipelines blindly. It should trust the specific registries, specific signatures, and also the specific identities. If pipeline can directly push anything into production, it means you skip the architecture and jump straight to hope that things will be fine, right? So we need to validate this as well. Then comes my favorite, monitoring and telemetry layer. So security architecture without visibility is actually imagination, right? So what we assess here in this layer is, can we see who triggered this pipeline? Can we trace an artifact from commit to production? Can we detect any unusual pipeline behavior and also get alert for that? So in this layer, logs are actually not optional, right? So they are the difference between, I'll usually say this, incident response and incident guessing. So that's where monitoring and telemetry comes into. So we assess all the points what we just discussed. And now you just zoom out and see things from a very high level, right? So when assessing a CI/CD, I usually don't start with tools, right? So I start with the trust questions around that. When I say trust questions, it can be who can do what, right? So that's very important. And what happens if this identity is compromised completely? Or how far does the trust propagate? Do we really have a boundary for that, right? And Architecture assessment is all about the blast radius, not about perfection. So let's focus on all this. And as usual, we'll go through a checklist here. This checklist is not a compliance list, so it's a kind of thinking aid for you, right? So if you can't confidently answer these questions, the architecture isn't understood by you, which means it is not secure, of course, right? So go through this and make sure this for all these questions you have answers and you are confident on all this. So security architects care less about the check marks, right, and more about the confidence under failure. So that's where we all wanted to focus. And some of the common architectural pain points, as usual. So every real environment actually has this, right? So say for example, your pipelines with admin access everywhere. Most of us would have seen this. Then secrets copied between jobs, that too in a temporary basis. Unsigned artifacts, because people will say, oh, we'll add it later, right? We all would have seen this. And no audit trail for who approved that. Even if we go backtrace, we'll not be able to find like who exactly approved this, from where exactly this commit happened. So all this are not just mistakes, they are design decisions that were never revisited. It's going to be trouble for all of us. So to wrap this up, CI/CD is not just an engineering concern. So it's a core security architecture layer, right? So pipeline are not production identities. Artifacts are trust objects. Visibility defines how bad things get when something breaks. So if you secure Kubernetes but ignore CI/CD, you protected the house, but you left the complete factory wide open. So think about that. Thanks for listening and see you in the next video.